In this video, we're going to talk about functions, and specifically, I'm going to talk about how to determine if one of these table of values or one of these mapping diagrams represents a function. So this is typically what you might be presented with in your homework or on a quiz. And as you can see, this table has an input, which is the x value, and an output. Input, output. Over here on the mapping diagram, on the left is the input, and on the right is the output. So for this particular video, we're going to focus mainly on the mapping diagrams. But before we do that, I want to talk a little bit about the intuition of a function. And by the time I review the intuition of a function and I review this set of mapping diagrams, you will be able to handle anything that is presented to you on a quiz or in your homework. Folks, let's talk about what a function is. A function, okay, as displayed or as represented by this green amorphous circle here, takes an input and creates an output. All right, so from your table, you recall the input is the x value and the output is the y value. Anything could be a function. A function could be an equation, or it could be a phrase, such as this one. This is a function that takes the name of a polygon or a shape and outputs the number of sides that it has. So if the input was triangle, the output would be that it has 3 sides. If the input was a square, the output is that it has 4 sides. If the input was a pentagon, the output is that it has 5 sides. Now, something very, very important. If this is truly a function, which I'm going to say yes it is, for every input, in this case the name of a shape or a polygon, you can only have one output. That makes it a true function. If I gave you the name triangle, you could only give me that it has 3 sides. A triangle can have 6 sides or 2 sides. A triangle has to have 3 sides. A square has to have 4 sides. But here's what's interesting. What if I gave you the input of a rectangle? Now, a rectangle has 4 sides. This, ladies and gentlemen, is still a valid function. It's okay for 2 separate inputs to have the same output and still be a function. What we can't have is one input with 2 outputs. You can't tell me with a straight face that a rectangle has 4 sides and it also has 6 sides. That would not fly. Let's look at some other examples. What if the input was someone's name and the output is their favorite ice cream flavor? Let's see where that takes us. If we use the name Jennifer and we ask her her favorite ice cream, she might say vanilla. If you ask Joe, he may say chocolate. So far, this is a valid function. Because look, if you ask Jen her favorite flavor, she can only give you one answer if it's truly her favorite. This question is not name some ice cream flavors that you like, that you're fond of. This is input someone's name, output their favorite flavor. Debbie comes along. Turns out her favorite is chocolate as well. That's okay. It's okay for 2 separate inputs to have the same output. What's not okay is if Debbie came along and said, I like chocolate and I like strawberry. That would invalidate this as a function. Next one. Given the name of a 10th grader, name of one of the student's teachers. Well, if I give you the name of John as an input, John has multiple teachers. He has Ms. Jones for math. He has Mr. Johnson for ELA, etc. So this is not a function. If you ask the name of a 10th grader, and I give you the name John, and I ask the name of his or her sister, he could have 3 sisters. This is not a function. If an input has more than one output, it is not a function. Okay, with that introduction, with that intuition, let's go to the mapping diagram and see where that takes us. I want you to pretend, ladies and gentlemen, that on the left is input and on the right is output. Use the ice cream flavor analogy. Okay, here we go. Here's your first input is -1. Its output is 8. Next input, 0. Its output is 8. So far, so good. This is like Jennifer and Debbie both having chocolate as their favorite ice cream. Next one. This individual likes that ice cream. That's okay. These 2 individuals both like that ice cream. That's okay. This individual likes this ice cream. This one likes that ice cream. This is all okay. This is a function. Let's do the next one. This has 1 output. 1 output. 1 output. Now look at this -9. 2 outputs. No good. That's like asking Jerry, what's your favorite ice cream? And he gives you strawberry and he gives you vanilla. This is not a function. Let's go to number 3. One output, 1 output, 2 outputs. This is Jennifer giving you 2 favorite ice creams. No good. You can only have 1 output for any input. This is okay. The fact that 3 and 6 both like 11. This is 2 people both liking chocolate. But 1 person cannot like chocolate and strawberry. Not a function. Number 4. 1 output, 1 output, 1 output, 1 output, 1 output, 1 output, 1 output. This looks good. It's okay that 4 and 10 both have 9 as an output. Next one, number 5. Looks okay, looks okay, looks okay, looks okay, looks okay, all okay. Last one. It's good, good. This has no output. So I would call this as not a function. Okay, let's look at 2 more examples. This is from one of my students' homework, and these are a little bit easier. Here's your input, the x values, 1 output. Here's an input, 1 output. Here's an input, 1 output. It's okay that they have the same output. This is Jennifer liking strawberry, John liking chocolate, Joe liking chocolate, and Paul liking mint chip. All of this is okay. This is a function. Look at this example. This is 1 person liking 2 different ice creams. It's 1 input with 2 outputs. This is not a function.